Hello folks, we're here to work on Unit 3 equations and homework number 3. This is our demo video and it is about two-step equations as well as equations that may be more complicated. So we started out working with one-step equations, and what we learned in one-step equations was that we needed to get the variable on one side all by itself. We say that we want to isolate the variable. We always start with the number that's hanging out next to it, or I should say to the side of it. We need to get rid of the 4. We also need to get rid of the 9 because that would get W by itself. But we need to know that the first one we have to deal with is the guy hanging out to the side, and the number that's sitting right in front of the variable, the coefficient of our variable, we're going to deal with second. So watch how that looks. I see that I have a -4 happening to my W. And again, the object of the game here is to get the W by itself. So if I add 4 to both sides, why to both sides? Because I have an equals in between them, and they're not going to be equal anymore unless I do the same thing on both sides every time. So I have to always keep my balance balanced by doing the same thing to both sides. When I do that, 32 and 4 gives me 36. My -4 and my +4 goes to 0. And what I have left on this side is 9W. Notice that that equal sign just falls straight down. It's still right there in between them. And now I know that 9W equals 36. I said at the top that we would get rid of the 9 second. And so we first dealt with the 4. Now we're going to deal with the 9. And we have to ask ourselves again, what is the 9 doing to the W? And I see multiplication here, that it's 9 times W. And I know that division undoes multiplication. I will always use a fraction bar for my division. It just is much simpler when you're trying to do algebra. 9 over 9 reduces to 1, telling me I have 1 W left or W left. I don't have to put the 1 in front of it. I know the coefficient is 1 when I don't put it on there. And then on the other side, 36 divided by 9 is 4. So what do I know? I know W is equal to 4. Not bad, right? I can check that answer. I can plug it into this W right here to make sure it's true. So let's just do that. Is 9 times 4 minus 4 equal to 32? Well, 9 times 4 is 36, minus 4 is 32. So when I do the math, I see that, yeah, it is true. That works. And you can check all your answers that way. The bottom of the screen asks us to now find the value of 4W. And you're going to see this in your homework, which is why I put it in the demo video for you. Oops, sorry, just trying to make this guy get out of my way for a minute. So if I know that W is equal to 4, I can now tell you what 4W is. 4W is 4 times 4, or 16. Let's try that again with this equation up here that looks a little bit backwards or goofy. So we need to look at it closely and ask ourselves, what are the things that are with the variables that we need to get rid of? It's your first instinct sometimes to go ahead and subtract 30 from both sides, but notice 30 is over here by itself. It's not with the variable. So it's not what I want to concentrate on. The two things that need to go away are this 5 and this 5. And if I could get those to go away, my variable A would be by itself. I know that I need to deal with this guy first, and the coefficient in front of the A, I always deal with last. So how do I get rid of +5? I do the opposite, or the inverse of that, which is to subtract 5, not 6. Sorry about that. Sometimes my brain just does funny things. I'll subtract 5 from both sides, again, keeping things equal, and remembering that when I subtract 5 from both sides, I'm thinking of this equal sign being the middle, and I have to do the same thing to each side. So subtracting 5, I get 5A over here because positive and negative 5 go away. My equal stays right in the middle, and I look at what is 30 minus 5, and it's 25. Now I can get rid of the 5 that's in front of my A, and since it says 5 times A, I need to do the inverse of that, which is dividing by 5, sorry. That leaves me with a equals 5. I've solved, and I can now, I'm going to leave it to you, go back in, put a 5 in for this a right there, and see if I get 30 when I do it. 5 times 5 is 25, plus 5 is 30. Looks good to me. Can I now find a minus 6? Sure I can. I'm simply going to say a is 5, and 5 minus 6 is negative 1. There's a minus 6. Two-step equations, they just take a little bit of concentration on your part. Now these have fractions in them. They make them look more difficult, but don't let them scare you. Fractions are not scary. We're doing the same thing. It might help you to notice this x over negative 2. I'm going to rewrite that this way and see if it makes sense to you. There is a 1 in front of the x. It's sometimes helpful to us to bring that coefficient out and make it on the side. I don't know if that helps you or not. It is always helpful to me to think of it as a coefficient instead of the divided by. Either way works. I'm going to change it this time. If you like it the other way, that's okay too. I'm still going to take care of this the way I did the last equation I dealt with. It's a two-step equation. There are two things bothering me. It has a negative 6. I need that to go away first. And again, the coefficient or the thing in front of the x will go away second. If I do this in the wrong order, I make my life difficult. So make sure that you're taking care of this guy out here first by, in this case, adding 6 to both sides. I have to get rid of negative 6. So 12 and 6, 18, equals, bringing it straight down. Sorry, guys. And let's see, negative 6 plus 6 went away. Negative 1/2 x is what I have left, and I think I'm going to write that back this direction, just kind of showing you what's going on. Same thing. Now I have x divided by negative 2, and if you recall on the last screen, we had x times 2. So we divided. But now we're dividing by negative 2. I need to do the inverse of that. I can think of it as multiplying by negative 2. I can think of it as multiplying by negative 2 over 1. However, it helps you to look at it. But I have to multiply by negative 2 because my x is divided by negative 2, and I want that to go away and x to be isolated by itself. And watch how this does that. Negative 2 reduces with negative 2, and it leaves me just x. Negative 2 times 18 is negative 36. I can think about plugging that back into this x. And if you just think about it, negative 32 divided by, negative 36 is what I thought my x was, divided by negative 2 is what? Positive 18, and positive 18 minus the 6 is going to give me the 12. So in my head, I just checked it. You might try to check that on paper. And we also need to make sure that we are plugging it in here. So I'm going to do that quickly. We think it's negative 36. Because now they're asking me, well, if you know x, what's the value of 2x minus 3? So I'm just going to plug it in to find out. Double 36 is negative 72, I hope, minus 3, negative 75. Let's try one more. I know this one looks really goofy, and I want to show you that it is the one that kind of breaks the rule. When we see addition or subtraction here, we need to go ahead and multiply by the guy on bottom first. So I'm going to multiply this by negative 3, and I'm going to multiply the other side by negative 3, and watch what happens. I get negative 6. My equals fall straight down. 3 times negative 2 times negative 3 gives me that negative 6. And on this side, look, it's going away, and that's kind of what I wanted. I wanted 15 plus y. Now I can simply subtract that 15 from both sides. I know I'm going kind of fast. You might want to slow it down. And make sure you're with me. When I add two negatives, I'm going to get a bigger negative, and I think here I'm going to get negative 21. I want to carefully plug that negative 21 into this y, and by carefully I mean this. See this negative sign? That guy stays there. Then I plug in for y as negative 21, and look how it's going to be negative, negative, and it's going to become positive. So that's where I want you to be careful plugging in. 21 minus 3, I think I'm going to get 18. And we just found out that negative y minus 3 is 18 if y is 21. We need to look at one more thing kind of quickly, and it is this idea of consecutive integers. Consecutive odd integers is what this says, but let's just hang on and talk about consecutive integers first. It sounds hard, it's really easy, so stay with me. Consecutive integers are numbers like 21, 22, 23, 24. That is 4 consecutive integers, simply 4 whole numbers. What if I want consecutive odd integers? Then I'll just skip 2, 21, 23, 25. Those are 3 consecutive odd integers. I am going to use this idea to come up with the perimeter of a triangle that is 33 if the sides are 3 consecutive odd integers. So this is what's interesting. If my first number is 21, and we're going to call that x for a moment, how would I get to the next consecutive integer? And I hope you tell me that it would be, well, x plus 1 would be the next number, Ms. Strong. I would just add 1 to it. And from here, how would I get to the next one? I think you would say I add 2. So if I'm looking for consecutive integers, one of them would be x, the next one x plus 1, the next one x plus 2. This question asked me for consecutive odd numbers. So watch what I have to do. It's kind of weird. I have to call this guy x, this guy x plus 2 because it's 2 more, right? And this guy x plus 4 because it's 4 more. So that's how I end up labeling my sides. And I can label them this guy x plus 2, and this guy x plus 4. If they are consecutive odd integers, I don't know where they start, but I know that they have to be 1, 2 more, and then 2 more again. In this particular problem, I'm asked for the perimeter of my triangle, so they're asking me to add this up. They're saying, what is x plus 2 plus x plus 4? They're actually not saying what is it, they're telling me it is 33. So see how I added the 3 sides of the triangle here. I'm going to kind of block them off. I don't have to, but there's my 1, 2, 3 sides. And I'm going to add that up. It looks like I have 3x plus 6 equals 33 because I put together my like terms. So x is 3x and 4 and 2 is 6. Now I'm going to solve this to find out what my x is, and that will tell me my side. So I kind of have to do that quick, and I don't have much room. So let's see how we do here. 33 minus 6 is going to be about 16. It's going to be about 26. 10.5.2, I think so, 26. And then I have 3x equals 26. And you know what just happened? I did not get a whole number, or I subtracted wrong. So in other words, I gave you rotten numbers for this problem. Let me see here. 26. Whoops. 27, because I can't add. Sorry. Yep. See, I use my calculator all the time, even for adding. So I subtracted wrong, and 33 minus 6 is really 27. So I am going to get a whole number for an answer, which is good. I'm going to get x is 9. Well, if I know that one side is 9, and I know they're consecutive odd integers, then I know this one must be 11, and this one must be 13. So I just found the 3 sides of my triangle. I know that was a little weird. I think you will get some practice in your homework. I hope so. I hope you will go and do your homework right now because I think you're ready for it. So give it a try. Have a great day. I will see you next time.